Welcome everyone to our Tech in 20 series today. Today we're going to be talking about DevOps and how that works, and this is a particularly important discussion today because it's so applicable to everything we do here at CA. And so as we do this, again, we're going to be doing live polling, and so you can text your answers to 22333 if you're in the United States, or anywhere in the world you can go online with a PC browser or your iPad or iPhone or whatever, and go to pollev.com/tech20 and answer the polls. Today our presenter is Nat Srinivasan, and he will be discussing this, and so we'll turn the time over to him now.
Thank you, Clayton. Thank you so much. It's great to be back in the Tech in 20 series. Thanks to everyone for taking the time to join the presentation today. Let's try and keep this interactive as much as we can, and have a discussion on this topic. So to start off, just want to set some context for this topic around what trends are accelerating the pace of development as we see around us, both within CA, customers that we talk to, and generally in the industry. Interesting sort of responses there. As expected, a lot of us are able to relate to the kind of mobile revolution that is sweeping amidst us, and that's clearly a major trend as enterprises are rolling out newer apps or extending their existing apps over to the mobile form factor because they see a huge BYOD trend and want to take advantage of that and enable both their employees and customers and partners as the mobile form factor takes stronger hold. There's also a lot of development pace that comes from having to keep up with competition, and specifically with respect to how, given how the playing field is so level now, and there's a lot of disruptive technologies always happening from startups and so on and so forth, leveraging commoditized off-the-shelf technology stacks and services that are available over the cloud and so on and so forth. So that's also driving quite a bit of development. And there's also a trend around automation. I'm a little surprised to see that's not being categorized here by this audience, but in addition to just general information technology, software applications, and so on and so forth, a lot of different business processes within enterprises are constantly getting automated as we speak. So that's also driving a lot of development activity. As we move forward, an interesting set of stats here that talk about how often software gets produced and deployed and changes get made to production infrastructure. If you look at companies that operate on web scale, companies like Facebook and e-commerce companies like Amazon, the volume of change, the velocity of change that these companies push out is astounding. Facebook, for instance, makes 2 updates to their production infrastructure every day, and Flickr apparently does 10 every day. And we are talking literally hundreds of thousands of production nodes that have to be touched, where code needs to be deployed and configuration needs to be updated, and so on. Another important thing here to note, how Amazon's deployments have been tracked by the company, and a significantly less number of such deployments cause an outage. And so you'll see later, this is a big important factor to consider in the realm of the DevOps philosophy. When we push code out, when we make changes to production, how is that holding up? How is that keeping the system running and available and stable? And even at that volume at which Amazon is running, they're able to keep a tighter control on the stability of their production infrastructure. A lot of you are pointing out deployment issues and capacity issues. Those are certainly important factors. And we'll see later how several enterprises that were asked to respond to a survey also pointed out those kinds of issues. Having to deal with post-deployment stability issues, performance issues, what have you, and sort of recovering from all that mess is what the DevOps philosophy, the DevOps concepts are really trying to take head on. If you take a small step back and look at how the general software development process and deployment and so on works, they've operated traditionally in a very siloed fashion. Requirements get spec'd by the product management team, by the marketing team. They sort of get thrown over the wall to the developers for them to come up with with a code, and they go off and function in a really disconnected mode away from the rest of the organization, and testing team is out there preparing their test scripts and waiting for their first build to start testing. And once they get into the test mode, that's when they start to discover how the software has got so much variance from what the product management team intended. And a similar such discovery happens when the development organization feels like they have got the software ready to go into production. They throw it over the wall, if you will, to the operations team. They try to deploy this to production, and it doesn't really stick. It comes right back into engineering. We couldn't deploy this build. We're not able to upgrade the existing stack. There are all kinds of performance issues that we're running into while running this newer version in production and so on. So you can sort of relate to the inefficiencies right throughout that cycle of producing newer versions, producing applications and deploying them to production. So the DevOps culture or philosophy is really a collection of tools and processes and way of getting all this done that attempts to bring all these various different stakeholders in the process in a deeply connected, collaborative fashion, such that the discovery of such issues happens right throughout the cycle. That's a key distinction. As opposed to making that discovery happen at specific chosen inflections within the complete continuum, how can we make the discovery sooner? How can we make the discovery continuous, such that software, when we roll it out to production, really works the way we want it to, really works the way it is intended. So
Nat, can I ask a quick question?
Sure.
So I got a question in the WebEx chat, and so the question is really, how does a company then change from doing it, say, a quarterly release or an annual release? When you start talking about having 10 releases a day, or all of this, how does a company make that change?
Well, first of all, the number of updates, number of releases that an enterprise has to make does not always have to be at that kind of velocity for these philosophies to take hold. Those are two separate ideas, right? For a company like Facebook or Amazon, they're constantly pushing updates out because that's how they can engage a consumer-oriented audience, a web-oriented audience. For an enterprise software company, the number of updates that have to be made do not necessarily have to be at the velocity. But the key thing is to introduce enough tools, enough processes, and enough sort of cultural change that brings all these stakeholders together. If you look at what I was mentioning in the previous slide, how do we connect product management, marketing, and development and testing so they can operate together in a highly collaborative fashion? That's what agile development is really trying to address, right? As opposed to requirements getting baked in a separate siloed fashion, getting thrown over the wall, and getting developed in a disconnected way, only for issues to be discovered really late in the development cycle. How can we bring these parties together? How can we get a daily stand-up review of the state of the development world, if you will? And that's really what agile development is all about. Extend that now to the next handoff between the engineering organization and the operations team. How can we bring them together so that developers are really thinking about not only making the software functional, but also testable and operatable, if you will, and monitorable in the production infrastructure. Similarly, the operations team can participate in the development process by providing enough insights into infrastructural constraints and characteristics that can be taken into account even during the software design phase. You don't want to run into a production issue with respect to a severe scalability limitation. If you knew about it earlier, you would account for it, you would build into it. So that's the idea. So it's a cultural and implementation that every company needs to invest in.
Makes sense. Okay.
So what does it look like, right? So we spoke about visual orientation. We spoke about tool sets. We spoke spoke about process changes and culture changes and so on. It sort of looks like a couple of these graphics here. We have tools that not only help teams manage software, with strict version control and configuration management and so on, but we're talking about being able to automate the complete source code fetch, build, deploy, monitor whether the correct build was deployed, run the test in an automated fashion, and produce an automated report, all at the click of a single button. And a lot of companies have invested in tools like this and processes like this that allow them to generate a build, pretty much at the click of a button and continuously right throughout the day. Every 15 minutes or so, a continuous integration process kicks in, checks the code out, runs the code through the build process, produces the next build, and it gets pushed continuously to the next stakeholder in the life cycle, if you will. A testing team doesn't need to wait for dev to take 4, 6, 8 weeks to produce the first testable build. Similarly, the operations team does not have to wait for 3, 4, 5, 6 months before they get a build from the development organization to host on a production-like test infrastructure. All of that can happen continuously right through the cycle of producing software. That's the whole idea of DevOps. How can we automate a lot of these tasks that are repeatable and bring all these parties together so they can consume the software that's being produced consistently on a daily basis and discover issues that need to be discovered early enough and can be fixed right throughout the process. So when we get to production, the software has already been fully baked. It's already been tested under known conditions, including production-like infrastructure, such that we don't run into any unknowns, in those scenarios. There are a few different tool sets that are being, called out in these graphics here. There are several others out as well in terms of how you build, how you configure, how you deploy, how you monitor, how you instrument, your code, how you produce artifacts against a build, and how you track them throughout the complete process of producing software. An interesting quote here that I want to share. Werner Vogel, who's the CTO of Amazon, has been a big principal in driving the DevOps movement. Amazon has one of the best maturity models in terms of implementing DevOps. And his quote here, which says, you build it, you run it, really sort of sums up that whole trust, right? An engineer at Amazon is really responsible for operating the software that he or she writes as well. So the way their operations, yeah? Is there a question?
So in this kind of a circumstance, do we have to have a different kind of testing software than we normally see to be able to do these small iterations of code to be able to ensure that they work correctly? Is that going to require new, testing and QA and monitoring tools as well?
Yeah, so on this continuum, right, so some companies have taken the maturity to a new level where they don't have developers versus testers versus operations folks. All of these are engineers. They write code, and the code does various different things. There is code to produce test artifacts. There is code to produce test automation frameworks. There is code to deploy. There is code to monitor. There is code to bring up infrastructure components, Linux server here, or a Windows virtual machine there, and establish a connection to the database server, if you will. All of those are codified in code and also managed in the config management system like source control rigorously as much as the actual software does. Of course, we also have the developers writing the software that the whole team is producing. So at the very end of that spectrum, everybody's writing code that either writes the real code or code that helps the other people write their code and make it work as well as it should. But that said, test automation is not new to the industry. It's always existed. But there have been serious limitations and constraints in what was automatable and what the team could deduct from those automation reports and how they could act on them. So there is continuous evolution and maturity of these tools where today it is possible, it is conceivable to run this complete infrastructure of this whole factory of producing software can be done completely automated end-to-end. but it requires serious discipline. It requires serious investment from the organization, where they do have to make some initial investment in terms of getting their frameworks together appropriately, getting their strategy about how to make the software testable in an automated fashion, how to make the software monitorable in an automated fashion. They have to make those investments upfront. If they do that, they can run this factory really efficiently. Now, moving further along here. So as I pointed out earlier, issues around deploying software, managing change in production infrastructure, and maintaining the scope of surprise that enterprises are often hit with is a big problem still with a lot of enterprises. Yes, there are companies like Facebook and Amazon and several other software ISV type companies that have a very rigorous maturity around DevOps philosophy, around agile development, and so on. But for a lot of other enterprises, this is still early days. They recognize the problem, but they don't know what to do about it. Some of them are beginning to think about DevOps. Some of them are beginning to think about agile development and so on. But still very early days if you look at the entire suite of applications being produced by all the enterprises out there. But it is clear from what DevOps can provide that we can discover issues early. We can attack those issues right throughout the cycle and get them fixed as soon as possible within that life cycle, which means we produce better software, better performing software, and on that note, we can have a happier bunch of customers, and all of that translates to a better bottom line for anybody that practices it. So why is this important for CA? CA, interestingly, has an amazing tool set around promoting this whole philosophy. Our tools that are capable of monitoring, for instance, APM. Today, it is thought of more in the context of how do I monitor my production infrastructure, but it can seriously also be applied to the entire life cycle. It can be applied to a beta testing phase, or it can be applied to smaller iterations of agile development, where as soon as a particular feature has been coded, it can be run through APM's monitoring capabilities. Similarly, data center automation has always been a big focus for and as companies look to extend their solutions to the cloud or leverage services from the cloud, deployment to cloud and consuming those services in an automated fashion becomes very, very important. And CA plays an important part in this space. CA should continue to extend its capabilities and solutions to this complete suite, such that it promotes the DevOps philosophy, and because it's only going to become a bigger trend within a broader suite of enterprises. It is all about the speed of delivery, absolutely. And speaking of speed of delivery, I feel we need to see some changes in philosophy even internally. How are we doing with respect to our own products? How fast do we produce them? How fast are we able to get to market and take advantage of the opportunities that are in front of us? Specific focus on DevOps philosophy and culture, and introducing the appropriate tool sets where, like I said, the entire development organization comes together and collaborates and discovers issues as quickly as they should, will make a big difference in terms of producing better performing, higher quality software quicker to market. So those are the thoughts that I wanted to share today on this topic. I am happy to answer any questions at this time, Clayton, so we can open up the line.
Samantha, can you check to see if there's any questions online?
At this time, I'd like to remind everyone, in order to ask a question, please press star, then the number 1 on your telephone keypad. Again, that's star, then the number 1. We will pause for just a moment to compile the Q&A roster.
While she's compiling that, can you answer that one? How does this work with agile methodologies?
Yeah, I was just about to. Yeah, that's a great question. So, if you think about the complete life cycle of gathering requirements, managing those requirements, prioritizing them, producing code that basically codifies those requirements, testing that code, delivering that to testable infrastructure, and then to production. If you look at the entire life cycle, agile development is about that first phase in that whole cycle, where we want to bring the product manager, the product marketing person who understands the customer and the market and who provides the requirements. with the development organization, with the developers and testers, so that they can collaborate and make sure that the software that is being produced is true to the intent that we are serving the market with. Now, DevOps is really about, it started off as a philosophy that attacked the latter part of the cycle, where once the software is produced and it is ready to be deployed to production infrastructure, we want to make sure that the dev and ops team can collaborate and make sure that the software that's been produced, A, can be deployed, and B, can be effectively monitored such that proactively issues that arise in production infrastructure can be quickly attended to by these teams. Some folks say the philosophy really extends to the complete cycle. We should really think of DevOps and Agile as two eyes of this same body, if you will, that have to be taken together seriously, applied together seriously, such that the complete life cycle becomes really efficient.
Any calls, Samantha, or any questions, Samantha?
There are no questions in queue at this time.
Okay, so Nat, if you'd like to move to the next slide and then summarize, then I'll then pass it back to me.
Yep. So to summarize, like I said, Agile development and DevOps are two critical underpinnings of a new way of developing software applications and software products, where all of the stakeholders involved in this process, everybody from those who represent the customer to the folks that actually produce the software, to those who test it and those who deploy and monitor it, all of them have to really collaborate in a highly interconnected fashion and be able to help each other such that they can all discover what they need to discover about how to write the software, how to test it, and how to deploy and monitor it. And that's what these two philosophies are about, and that's what a lot of the modern tool sets that these are all about.
Thank you. I think this is fascinating, and I think certainly from our perspective, whether we're looking at an environment where we're creating work to go show to people, or whether we're talking to customers who are creating software or work to show others, I think it's a really helpful thing to think about and to how we can really position and help our customers with this same problem, because it appears that everyone would have this problem, and trying to make it faster, trying to make it better, and improve the quality in a very fast time frame. So I really appreciate the information and look forward to having more discussions offline about this and so on. If any of you have any questions, you can send Nat an email and he can help you with that. And so we'll look forward to next week. We're going to change gears just a little bit and talk about security, and specifically 802.1x security, and not just WPA2 or WEP. We're going to talk this more holistically, and then also what's coming up for that, and we look forward to doing that and look forward to having you here. So until next week, good selling.